Hello, guys. Welcome you all to this sixth part of our Python interview series. Thank you for the amazing feedback, and I've got a lot of viewership as well. So thank you for all of that amazing response. So today we are going to cover our sixth, and this is just an extended cut of our previously covered lists in Python. So we have covered list in three different parts as part 1, part 2, and part 3. So today it is going to be the extended cut, and this will cover the other parts of the operations that are left out from our previous tutorial. Okay, so before we jump to the video, who are we? We are Data Valley, the fastest growing edtech company and this video is being taught to you by Franklin, myself. I've got almost 3+ years of experience as a data engineer. So if you're new here, feel free to connect with me in LinkedIn. Let's all connect and let's all build a professional network of people who like to talk about coding, who like to talk about tech, who like to talk about data engineering and stuff. So I have I specialize in multiple tools, but we'll be going through all that sooner in our videos. But for now, just feel free to connect with me in LinkedIn. Let's build our community. So to continue with our sixth part in our series, we pretty much covered a lot of portions in our previous video. So before we discuss that, you all know the routine. Feel free to grab a coffee, come sit and chill for an hour, have your notes ready, have your pen ready, say to your parents, your siblings, everyone, see, I'm going to be focused for an hour, do not disturb me, I'm going to practice. And most important advice I would give you is do hands on. Okay, don't just listen, do hands on, do practice. If you feel worst about listening and writing code at the same time, maybe I'll advise, okay, listen for an hour. At least after the session is over, feel free to do hands on. And sooner I'll be providing all these notebook materials in my GitHub as well, so you will be getting access to it. If you feel if you are a person who would be comfortable having notes in your hand, so you can download it from GitHub. And soon I will I'll upload that link into my video description as well. So continue watching, stay tuned. So if you have any questions, feel free to drop your questions in the comment section. I will try to address it either in this session or in the next video that I'll be uploading. So what did we cover previously in our list chapter? So in our first chapter, we covered what is a list, what are the key characteristics of a list, and then we learned about few built-in methods and functions, which includes like append function, then an extend function, an insert function. Then we learned how to remove an element from a particular index using pop, or just to remove an element based on the value. Then about clearing a list, then how to find the index of an element. And then in our second part of our list series, we jump to learn few more built-in methods, which includes count method, by which you can get to know the frequency of particular element within a list. Then sort method, by which you can sort the order of your elements, either numerical or alphabetical. And it also depends on certain key functionalities that you provide. Also, we have two types of sorting. One is the ascending order and the other one is descending order. Then we learnt about the reverse method, where you reverse the entire list into a reversed positional index. So all your index get reversed, and therefore your elements get reversed as well. Then you learnt about how to create a shallow copy. Then you learnt about enumerate function and zip function. So in enumerate, you create an enumerate object which would initiate a counter function along with your original list. Therefore, you would get an enumerate object. Then in zip function, we learned that two or more iterables could be combined together to form a zipped object. So all your iterables will combine together to form your zipped object. And then in our third part of our list series, we covered few more operations, which includes indexing operation. So indexing operation is where you provide the index number, and by which you get to access the particular element from that. Then we learned about slicing. So in slicing, you could get a subsection of a particular list. And then we learned about looping operation. So we have two types of looping operation. One is for loop and the other one is while loop. For loop is very definitive, so it's going to loop or iterate again and again for your loop for a fixed number of times. But talking about while loop, the while loop is going to iterate again and again as long as the condition not met. So you provide a condition, and as long as that condition is satisfied, or as long as the condition is not satisfied, your looping function is going to iterate through again and again. And then we learnt about comprehension operation in list, in other words, the list comprehension. It is a form in which you could write an efficient, concise, and smaller, expressive, compact. So, and it also combines the functionality of a for loop and if condition. So, this is very compact version of writing your code. And today, to our sixth video of this series, we are going to cover up a few more operations that are in relevance to your. To start with, I mentioned list comprehension in here again. There is a reason I mentioned it again as well, because you might be wondering, in yesterday's series, the last part what we discussed was list comprehension, and why do we have it again here? List comprehension is bit crucial for all your interviews or in your real world setup. It is not necessary that you'd be, you have to use your list comprehension. But what I would suggest is that if you use list comprehension, you would become a better coder. So instead of multiple lines of code, if you can write all those code in a single line, you would be called a pro, right? You will become a pro coder. So I wish all the data valiants here to become a pro coder. So this is one of the important technique while writing Python. So make sure that you pay attention towards this concept. By concept, we all learned yesterday, how concise it is, why it is efficient, in how it is providing us better readability. We covered few of those topics. Today, we are just extending it by just giving you extra code questions. Okay, so if you could see those questions, and it'll help you to understand better. So that's the point of bringing this chapter again. I'll start with the syntax again. So for a list comprehension, you have to specify a list name, which is going to be the name of your list that you're creating via, and then it takes a square bracket, as you can see, and then you have to mention your expression, and then you have your for loop. So for item in iterable, so item can be a naming convention for your individual elements that you access, and provide an temporary variable. And then iterable is anything that you can loop through. So it can be a string, it can be list, it can be dictionary, it can be a tuple. So all of these are iterable. So you're going to provide from which you're going to loop. So you provide the name of your uh, the list that you want to work on, and then you have if condition, which is option. Let's see the explanations in short. The expression is an operation which gets performed on each of your item that is included in the list. It can be a variable, a function call, or any valid Python. So not necessarily the expression just have to be some kind of functional call or a formula. It can take any kind of Python expression, to be honest. And then yesterday we saw a few of expressions, right? So not only expressions, it can take in functional calls as well. So be thorough about it. And then talking about item, this is a temporary variable, as I said earlier. So when each of the elements from this list gets accessed, each of these individual elements are given a name. So that is what I call as temporary variable. And then you have iterable. So this is the sequence in which you are trying to access the elements, and you're trying to apply an expression to each of those elements within that. So that is your iterable in here. And an iterable can be of a type list, tuple, range. It can be even dictionary, whatever not. And then you have if conditional. So this is an optional parameter that you can include along with your list comprehension, by which you get to filter what elements can be qualified for the evaluation. So let's say I have an expression where it says that, even yesterday in our coding problem we discussed about it, right? So we want to extract only the even numbers. So what did we do? So we used if clause, and then the particular equation. So the number percentage 2 is equal to 0 will give you a value, those that are only divisible by number 2. So you're going to get only the even numbers. So that is how you evaluate So the if condition plays a crucial role as well, because when you write the complex code, that's when the if conditions are very widely used. Okay, we have seen enough of list comprehension theory. Let's jump to our code now. So how to create a new list containing the squares of even numbers from 1 to 10 using list comprehension. In yesterday's session, we saw that how to create a new list that contains only the even number. But today I've got you with a bit complex question. Okay, it's not exactly complex. You're going step by step, right? So you'll be getting there. Do not worry about it. How to create a new list. So try to understand the question. Yes, you want to create a new list, and then what it should contain. It should contain only the squares of you should have only the squares of your even number. So you're going to filter for your even numbers, and then you're going to square those numbers. And what is the range you want? So from 1 to 10. So that is the set of numbers that you're going to use to perform list comprehension. All right. So we have learned, or we have dissected the question. Now let's try to implement those. All right. First, I've got an iterable here. So I've already said you what is an iterable. Iterable can be a range, it can be a list, it can be a tuple. So anything that can iterate again and again is an iterable. All right. So I've got the iterable here. Oh, sorry. So I've got my iterable here, and then I've got my list comprehension. I'll explain those, and then I've got my print statement. So what does this iterable do in here? So I've already taught you about the range function, right? So what happens in a range function? So you get to choose your numbers. Okay. So for example, when I say range from 1 to 11, I would get those numbers from that range. So starting from 1, it goes onwards. So I can get up to, all right. So whatever the range I specify, I'm going to get all those numbers. And you got to remember that in range function, the last number is exclusive. Okay. So 1 is the start here, and the range is, and the 11 is the stop here. And talking about your stop parameter, the number that you specify, it is always n minus 1. So what do I mean by n minus 1? The value is exclusive of that particular number. So if you specify 11, your range extends only up to 10. So it stops at 10. Okay. So that is how your iterable is working in here. And then let's talk about the list comprehension formula that we have got here. So what is the even squares here? So this is my variable for the list. Okay. And then what have I got? I put these square brackets. So do not forget, for your list comprehension, you always have to use a square bracket. Then I've got an expression here. Okay. So this is my expression part. So what does this do? So this is nothing but, for example, let's say I have got number 2. So 2 into 2, which is a square root, right? So this gives you a square root of a number. And you might be wondering, why did I mention x? So x is a naming convention, or an temporary alias that I give to each element I access from my source. And then I've gotten here a for loop. So I've got my for loop, which is, so x is my temporary variable again, and numbers is my source sequence. So as you see here, this is my source sequence. All right, for x and numbers. And then I've got my if statement. So what happens in my if statement? So this is going to get only those that are even numbers. Okay, this, how does it work? For instance, let's say I have uh, I have 4. So 4 divided by 2, okay, is an will give me 2, which is an even number, right? So similarly, any number that you've got, if you could further divide it by 2, then it becomes an even number. So anything that is of an even number, I would be filtering it for my list comprehension. And you all know about print statements. So it just prints your result out. In simple or in concise way, x into x is your expression for squaring your number. So the squaring actually happens here, okay? So how this code works is, first your for loop works. It accesses the particular element from your list, okay? It gives a temporary variable called x, okay? It gets an element x from your source list, and then to this x, it applies this expression, all right? For example, let's say I want to multiply everything by 2. In that case, this is my expression. Asterisk 2 or multiplied by 2 gives me a multiplied value for my elements in the list. I hope you all get it. So this is the expression you apply to this elements you get out from your list. So in our case, we are not multiplying, but we are finding the, so hence I've got x into x, or in other words, the element accessed from here. So if it's accessing 3, so it's 3 into 3, 4 into 4, 5 into 5. So each time the element is extracted out, the expression gets applied to that particular element. So before that, there is also a condition if clause. So first step happening here is the element is extracted out, and then to that element it checks if the value is divisible by 2. Is that an even number basically? So if the number is not satisfied, it doesn't go to your further stage where you square those number. All right, so this is the case only when we use if clause. If we don't use if clause, it does a for loop, goes to the expression, and then it prints again and then iterates. But if you have an if statement, this goes for your for statement first, where the element is extracted out, then the condition is checked for, we have an if filter condition, and then if it is satisfied, then it goes to the expression part. All right, so let's run this code to check has been, the output of this code. Okay, it's running. Okay, the sources are getting booted up. Let's just give like 5 seconds. Yes, you have got it. So as you see here, the output that you've got here is 4, 16, 36, 64, and 100. So the code functionality is very obvious. How I'm saying it is very obvious of what the result it has printed. You might be wondering, for instance, let's say for x in numbers. So each time the element gets it out, okay, each time the number is being extracted from your list, it goes for an expression. In that case, it would make an error out, okay, because you're not printing the even number. But in your case, you want only the list that contains the squares of even numbers only, and hence whenever the element is extracted, the filtering process is done straight away, and only after the filtering process the expression gets applied through. So that's why you have got the result as 4, 16, 36, 64, and 100. All right, now to our next part. What is membership testing operation? Okay, membership testing in Python refers to a process where you check, does the particular element exist within a list. For example, let's say I have a list called apple, cherry, and berry. And now I can use the membership testing operation to find if I have the particular element within that list. For instance, let me have a membership testing where I want to check if apple is present in that case, when I ask if apple is present, my list is going to check one by one if that particular element is present or not. If that particular element is present, you're going to return true, and in case if it is not present, it is going to return. Let's take it in a very simple logical way. I'm asking you, for example, I'm asking you, hey mate, do you have a pen? What is your response? If you have a pen, you're going to tell, yes, I do have a pen. So in Python context, you're returning me true. If you don't have a pen, you're going to tell me, hey Frank, I don't have a pen. So in that case, your return is exactly similar in Python as well. You just check whatever your query is, if it is present in the particular list. All right, and to achieve your membership testing, you have to use two kind of operators. The first one is the in operator, and the next one is not in operator. I think it's very much understandable of what this operator signifies. So what do I mean by in and what do I mean by not in? So all I'm asking is, do I have a particular fruit? For instance, with our previous example, I can ask, do I have apple in the fruits list? Or I can ask, I hope I do not have apple in my fruits list. So either you want to check if it is present or not, or in a different context, you can ask, I want to make sure that the particular element is not present in that list. So it works in two ways, and the operators are in and not in. First, let's jump in deep for the in operator. The in operator returns true if the specified element is found within the list and false otherwise. Okay, what's happening is I'm asking if the particular element is present within a list. And let's say you have it. If you're having it, you're just going to return true. If it is not present, then you would be returning false. That is all. That is very simple, isn't it? A membership testing is very simple. So let's see how this works in our code, because I know you're all bright. I know you're all intelligent. You would get all the theory. But with the coding part, it comes only with the hands on. So you might be a brainy fellow, but you have to work on your code. So let's see how this can be implemented in our code to test the member within a list. First, I've got a list here called my list, and it has elements 10, 20, 30, 40, and so that is my list. And to that list, I want to check if 30 is in that list. All right. So I want to check if the particular member, that is 30, is present in the, you can consider this in your real time scenario as well. For instance, I might be part of any group. Let's say I'm part of an IT group. Okay, I have an IT club. For instance, let's say you have an IT club. You might be asking if Franklin is part of IT club, and what would happen? The club or the members in the club would check, okay, Franklin, he's not a member of a club, or other way around, they would say yes, Franklin is a member of this club. Similarly, you're just checking, let's imagine the my list to be a club. So you have got a club called my list, which is having 5 members, and then you're asking, is member 30 present in the list? So similarly, you're just going to return true or false. True in the place if the element is present, and false if the element is not. See how I've done the code. I'm using if conditionals to check my membership test. So if 30 in my list, so this is the keyword here. So make sure you pay attention to this. So in is the operator that you use to check your membership testing. If 30 in my list, then prints if it is present. Else, if it is not present in the list, print that it is not present in the list. Let me run this code. And as you can see here, I've got my print statement here, which says that 30 is present in the list. And especially you might be wondering, to my eyes, yes, I can see that the particular value is present in the list. Why should I even use an in operator? Talking in Python context, or any, Python development case, or a data engineering use case, there would be scenarios where you want to check if particular element is present within the list. So you want to check the membership again and again. For example, let's say you have a database operation. In a database operation, uh, let's say you already have a member. Okay, you have a row which has your customer data. You just want to check the membership. Not every time you want to add the same member again and again, isn't it? Let's say you have a customer named Franklin. You don't want to add my same details again and again. And you can do it, but the problem is you're being very inefficient. You're making the performance a degradable one. So when you think as a Python developer, or a database engineer, or a data engineer, in any context, you want to write an efficient code which improves the performance. So by this process, it's like a check that you're placing, and hence the functionality of your code has been improved. Coming to our next question, I want to check if 60 is in the list. We have seen that 30 is present in the list, and you have got a good answer there. What would happen if a particular element is not present in the list? Would it return an error, or would it give an answer out? So your return value is mostly of Boolean type, right? So you would either get true or false. But let's see if it would throw out error or it wouldn't throw out error. I say it wouldn't throw out error. All right. So we checked if 60 is present in the list. Yes, as you can see, we don't have it. And instead of returning an error, it has given us an answer, which means that when the particular member is not present in the list, all you get to return is a value rather than an error. So because the member 60 is not present in the list, I've got an answer saying that yes, it is not present in the list. Now to our not in operator. So not in operator is exactly opposite to our in operator. The not in operator returns true if the specified element is not found within the list, and false otherwise. It is essentially the logical negation of the in operator. So what do I mean by the logical negation of the in operator? So while you use the in operator, if an element is present, you get to return it with, but if you use not an operator, if the element is present, then it would return false. So you are getting a reversed logical functionality. So there is a logical negation happening. So as in and not an operator are exactly opposite. If it is present, you would get true. If it is not present, you would get false in your in operator. But with not an operator, if the element is present, you would get false, and the element is not present, you would get true. So you're getting uh, alternate or a negated value. It's a bit different, right? It's a logically different, and hence you're getting a different result. Let's see that with our code. So I've got a list here saying apple, banana, and cherry. So my list has three elements, and now I want to check that if grape is present in my list above. So as you can see here, we don't have grape, but I want to check it. Now how I'm doing it, if grape not in my list, then print this statement. Else go for this statement which says that grape is in the list. Let's see what does it print. It prints me grape is not in the list. Okay, I explained you about the logical negation. So let's check how it is a bit different to our in operator as well. So if grape in my list, so I'm just changing the statements for better understanding. See, in this case, you'd have got here, if it is not present, it is a true value. If it is present, it is a false value for a not an operator. If you use in operator, this is true here and this is false. Okay. So in any way that you consider, what's happening here is as long as the conditions are met, it is true. So if it is in, it is true. Even if it is not in, it is true. But the difference here is the logical negation that's happening. So make sure that you are well aware about the operators that you're using within your. Okay. We have seen that if particular element is not present using the in operator, it returns the false statement and then it would print your statement as well. Let's see how that would work with our not an operator. Now I'm checking if banana not in my list. Banana is not in the list. Printed that for me. Else, if it is not present or if the logical condition is false, then print banana is in the simple. So not in should be true. If it is true, then it prints this. If it is not happening, the logical negation points to a false statement, which in turn would print banana is in the list. Let's see if it is true that the fruit is present in the list. It has printed that banana is in the list. Do we have banana in the list? Yes, we can see that it is present. So because it is present, it would return true. So this print statement has been neglected or ignored or skipped, and then it has gone to the false condition. All right, so that is how your in and not in operator works for your membership. And then we have our length function. We did see about length function previously in our codes as well. For instance, with for loop we did check about the range function and length. So but we didn't cover it detailedly because I said that we'll be covering that detailedly later in our chat. And today is the day we have got a length function. So let's dive deep to know about it. The length of the list refers to the total number of elements or items contained within that list. So what do I mean by that? So what I'm trying to tell here is that let's say I have sorry, let's say I have got a list called my list, and then whatever the quantity of the element within a list, that is what the length function refers to. So in this context, let's say I have got 1 comma 2 comma 3 comma 4. What is the quantity of elements within the list? If you would have paid attention, the answer is 4. So length is, so whatever the number of elements is present within the list, that is the actual count or the length of your. This is a very fundamental property of any list, because any list would have a set of size, right? It can be, any bigger or any smaller, doesn't matter. But as a fundamental property, every list would have a, so the length function would denote the size of it. The most common and efficient way to determine the length of a list in Python is by using the built-in length function. So to perform a length operation, you use the length function, which is a built-in function in your Python. Let's see the syntax. The syntax goes like this: length function with a round bracket, and then you mention the iterable. So iterable in the context of our list, so you have to specify your list name. So length round bracket, and then you have to mention for which list would you like to know the length. Now Let me create a list. Okay, I'm creating a list called fruits with few elements in it called apple, banana, cherry, and so to this list I wanna the size of my list. So how am I going to do that? I'm going to give, or I'm going to create a temporary, or let's say not temporary, I'm creating a variable. Okay, so I'm mentioning a variable called list length, and then I'm extracting the length out from my fruits. So this is your syntax, right? So length function, and then your iterable name. So iterable in this context is fruits. So you mention your fruits, the source list, and then now when you specify it, you can check the length. So you would have got the list length. Now what I'm going to do is I'm going to print it. So when I print it, it shows that the length of the fruits list is, you might be wondering, oh, this is very huge to write, so how am I going to write it? Do not worry about it. I have a session planned where I'll be teaching about the print statements, the varieties, and how do you print it. But for now, just know that I've extracted the result out from my variable. If you need it in simple, I'll show you as well. So print, what am I printing? I'm printing fruits. Sorry, I'm printing the list length. So when I print it, I can see that value 4 has been printed. So that is the length of my. Let's do the same with an empty list as well. So how do I create an empty list? For an empty list, I just specify a naming variable, empty list, and then I denote it with square brackets with no values mentioned within my square bracket. All right. So to this empty list, what I'm trying to do is I'm creating a value. So what is the benefit of creating a variable there? So what's happening here? When I create the variable here, I get to access it. In the above, you saw that because I got the value in a separate variable as list length, I was able to print it, right? I was able to print it easier. Similarly, if you get the temporary variable out, okay, so you have got empty list length. So this is the variable I'm providing to the result that has been fetched from my length function. So typically if you run just len of empty list, you'll be getting a certain value, right? For instance, there is other way we can print as well. For example, in the above statement, print, so I can use my length function directly here, and then I can input my iterable as well. So fruits is my iterable here, right? So this is my list. So I just pick it up, I put it here. When I print it, I still get the result. All right. So instead of using, mentioning such a big statement like length of fruits, it is not a better value code. So what you can do is just get a variable name for your function. One benefit is that you can reuse that particular variable again and again in your code. So when I print this, so I've got the length of my empty list. Here is my variable name called empty list length. And then when I put that into my print statement and then I print it, it gives me saying that the value is 0. Why is it 0? The value is 0 because it is an empty list. So we created an empty list, right? So you got no elements within, and therefore we have got an value as 0. So our final question of the day, it is bit of a big process, but pay attention for next 15 minutes. This is very important as well. So what is a type checking? So type checking is a process to verify what is the data type of all the elements within a list, or to check the type of the list itself. So Python by default supports a mixed data type, right? So for example, what are the data types we have? So we have, for instance, let's say 1 comma 2 comma 3. So this is integer type. Okay, then what do we have? We have string type. So let's say I'm putting Frank. So this is a string type. And then what do we have? We have, let's say, 1.0, 2.0. So this signifies your float type. And last but not the least, we have true, comma. In that case, you have Boolean. So these are the types or the data types that you have for your Python. So what happens is that, and by default, Python list supports adding mixed types of elements in your list. So there might be a scenario where you need to check if the particular element is of a particular type, or there might be a scenario where the list that you provide is of a type list at all. because you have varieties of data structure types as well. So what are the data structure types that we have? We have lists, we have dictionaries, we have dictionary, we have tuple, we have so list usually comes with a square bracket. Dictionary usually comes with curly brackets with key is to value pair. Tuple usually comes with a round bracket, and then set doesn't allow duplicates. Okay, so while Python is a dynamically typed language, meaning type checks primarily occur at runtime, understanding and performing type checks is crucial for writing robust and predictable code, especially when dealing with lists that might contain diverse. So Python is a dynamically typed language. So what do I mean by a dynamically typed language? For instance, let's say first I say a is equal to, and then when I print it, it is going to give me, what would it print? It would say that is of, let's say now I'm changing a is equal to a new value, okay? And now when I print it, it would print Frank. So you might be wondering, okay, is that because I just put value and then I'm printing it, the a has fetched the value to be 5? Or is it because just I've mentioned it here, and next to that I've immediately mentioned the print statement? Is that why it is printing Frank? Python is dynamically typed, so no matter what, whenever you get the value out, it is going to give you the last added value. All right, so whatever the last assigned value we have mentioned for a particular variable, that is what you get it printed again and again, or that is the value you return again and again. So because Python is a dynamically typed language and the checks happen at runtime, so Python is an interpreted language, right? Not a compiled language. In compiled languages, you just compile all the code and submit. But in interpreted language, each line of code runs in a real runtime. Okay, so all the type checks or whatever you know the checks that has to be gone through, the Python code goes line by line. Okay, so it's an interpreted language. So in that scenario, you have to make sure that you're well aware about type checks because it would impact your performance. And while considering that you might be writing a robust and a predictable code. So what do I mean by robust? You might be writing a complex code. In that case, if you have type checking in place, you can ensure that your code doesn't break out. Your data that you're dealing with rightly being used within your, so make sure that you have type checks within your code, which will improve your performance as well. Okay. Now, I've already said you that with type checking, there are two things that you do. One, you check if there is a particular element within a list, or I mean, what do I mean by an element is you check for the type of an element within a list. And the second type is where you check if the list itself is of a list. Okay, let's see that in action. First, what I'm going to show you is I'm checking if the type of a list is a list. So what I'm going to do is to check for the, you have two functionalities in your Python. So the first one is type function, and the next one is instance function. So these are the two functions that you use to check your type. First, I'm creating a list called my variable. How do I know it is a list? Because I've used a square bracket, and that's how I'm sure that it is a, let me create the list called my variable. And then there is a simpler way that you can do it. For example, you can just put in type and then type your iterable name, that in our case is my variable. If I run this, I can see that it is giving me the list. All right, this is okay just because we are doing an interactive work, and hence you can just check the type in a real runtime. Okay, because it's interactive, you would get to know the result immediately. If it comes to the robust code, you need to have all this code already in place. So how we do that is we use an if conditional statement. Okay, so if type of my variable check operator, so I have got is equal to list, then show, then just print me that okay, it's a list. Else say that if it is of not a list type, then say it is not a list. Let me run this code, and we have already seen that because we checked it. Is it type of my variable is list? So because my variable has filtered through the condition called if it is a list, and in our case it is true, it has given us the true statement, which is my variable is a list. Let me show you another example. I've got my variable here, But in here, this is not a list. As you observe, I've got a round bracket. So with round brackets, you can be very sure that it is a tuple. So if I check this type, it is going to print me. And now I want to check, okay, if my variable, or in this place we have got my variable, right? So I want to check if my variable type is of a list. So run an if statement to find it. So when I run it, it says that my variable is not a list. Why is that? Because this would return a tuple. So when I run this function, it would actually return tuple, right? So as you see here, type of my variable is tuple. So if I verify that tuple is equal to list, in this case, it is false, right? It doesn't satisfy. So because it hasn't satisfied, it jumps to the next statement, else condition. Okay. Okay. And now we have one more functionality within to check the type checking, that is called isInstance. So we use isInstance function or a type function to check for the. So how does an isInstance work? So the syntax goes like isInstance function, and it would take two parameters called the object and then the class info. So the object parameter verifies what object to be checked, and the class info would take in the information which type you want to have a look, or do you want to check if it is the particular object is from a particular class. I will discuss about all these objects and class when we discuss about object oriented programming, but for now know that a class and oops is how you create, a class is how you create an object. So class provides you with functionalities to create an object. So if class could help you to create an object, there is also a way that you can check if that particular object belongs to the particular class. So you can use for that, or in our case what we are seeing currently, we can check the type of a particular object as well. So first you have to mention what object you want to look for. So object in this sense is like it can be a variable, which means that it can be a tuple type, it can be of a, the variable can be of any type, right? Because variable is just an assigning character. So here this is my variable, but it can take any value to it. For example, in here it's a tuple. In the previous one we had a list, so in here we have a list. So it can be an any object, but we got to mention the object name, and then we have to mention the class info, or you can mention what is the type you're looking for, or what is the type you're looking forward to verify. I've got here another variable is equal to hello, and to that what I'm doing here is if is instance. Okay, so this is the syntax I've got. So I've got an if statement here, and then I'm checking is instance. I'm providing it with my object type. So what is my object here? My object here is another variable that I've created here. So object variable in the above has a value called hello, which is of a string type. So I'm passing my object here, another variable, and then I want to check it against if it is a list type. So in the place of a class info, I'm providing my in which I want the comparison to be performed. So when I print, what it would give is another variable is a list. It would become true only if this is a list. But what is my another variable? What is the type of it? So if I verify it, type of another variable. So I've already said it. If you remember, what is the answer? It is of a string type. So str denotes. When I print this, I can see that it says me that no, it is not a list. So that is how you use your isInstance function to check for your. Okay, we have done all this to check whatever variable type or whatever object type is or whatever list type is. Now I want to check if each element of a list is of a particular type. So how do I do that? So I already said you, right, you have two types. One is to check if the whole list itself is of a list type, and the next one is if all the elements within a list is of a particular. So what happens here is if you want to check all the elements within a list, you gotta iterate through each of that elements within the list, and then once you iterate as in the above, similarly you use the if statements to compare, or you get to know using your type function or isInstance function, which will be applied to each of your element to know about the type of that element. So what I'm trying to do here is I've got a list with mixed data type. So as you all know, Python list supports multiple objects of multiple elements of different data type. So in here I've got 1, which is an integer. I've got apple, which is a I've got 3.14, which is of a float type or a decimal. Then I've got true, which is of a boolean type. And now what I want to check is check if all the elements are integers. So what I'm trying to do here is I've created a variable called all integers. So this is a condition I'm giving to my uh, variable. So I'm assigning a boolean value to my variable called all integers. So if all integers, if all the elements within a list are integers, then the condition is all right. And now this is the crucial part. What I'm trying to say here is for item in mixed list. So you all know that item denotes your temporary variable name. So for item in mixed list, if not is instance item comma integer. So what's happening here, for item would surf through each element. So it would iterate again and again and gets to access each element individually. So from this source list, go through each element and then check if not is instance. So there is two way. If I can check if is instance of a integer data type. But for now, let's go through if not. If not is instance, and you all know the parameter name. First takes the object, and then it takes the class info or your data type that you're looking. So what I'm trying to do here, I'm applying my object here. So what is my object here? So this is the name for the individual objects, right? So item, I'm just specifying it. So the variable name, and then I'm looking forward if it is of a integer data type. And then you can notice that I have changed the condition to false. Why is that? Because I've used if not. So if it is of an instance, then the integers are true, right? I'm just saying if the element is not of integer type, change the condition to false and then break out of the loop. So instead of running through the list again and again, let's say in our example, okay, first it goes to the 1, okay, it gets the naming variable called item. So the item is equal to 1, and then it checks what is the item here, 1. So 1 comma integer, is 1 an integer type? Yes, it is an integer data type. And then if that is true, so if it is not, then it would false out. But in our first case it is true, so the condition wouldn't change, it would exit the code. But now let's say I'm taking in apple. So apple is my item, apple passes through, it gets to check against isInstance method, asking if it is of a type integer. So when apple is not of an integer type, so here, right, if it is not, the condition is broken, right? So in that case, when this statement becomes true, I'm reversing my condition here. So initially we started with all integers is equal to true. Now I'm changing it to all integers is equal to false. When the condition is changed out of the loop, and then if all are integers, so if all integers straight away means that if all integers is equal to true. So if it is true, then print that yes, all the elements in the mixed list are true. Else just denotes that all integers is equal to false. Okay, so if all integers, you might be wondering why I didn't mention if all integers is equal to true. By default, when I put if all integers, it means that it is a true statement. Okay, then print that all elements in the mixed list are integers, or just say that not all elements in the mixed list are integers. Let me run this to check. Okay, what has happened, it has given me a print statement saying that not all elements in mixed list are integer. Are you sure about it? Yes, because first it accessed 1 and it knows that it is an integer. Next it accessed apple and it knows that it is of a string type. It has broken out of the code and then it passes through the next loop, and then because the condition has become false, it is saying me that not all elements in the mixed list are integers. All right, next type is I want to check for specific type within my. So what I want to do is I want to run a code which would say that what is the type of each element within a list. So my list is having a mixed type, right? So 1 apple, 3.14 true, which is of integer, string, float, and boolean value. Now what I'm trying to do here is access through each of these elements, and if it is of a string type, then print which element is a string. If this condition is not met, go to elif and say that okay, the next element that is not a string, we verified it against a float, we found it to be a float. If it satisfies the float condition, then print that element for me. Let's print this. Now in the above case, it has gone through the loop. Whatever is of a string type has been printed to me. So apple, right? So let me add one more string so that it understands better. So I've got 2 strings in my mixed list. And when I run it, it says that, you know, Apple is a string, 3.14 is a float, Frank is a string. So your element gets compared to each of these object type, and then whatever the element, the condition becomes true, the particular statements get printed. Now let's talk about a scenario where a list is expected to contain only numerical values for your calculation. So you want to perform a calculation. To perform a calculation, you need only the integers. So you want to check if all the elements to be calculated are of an integer data type. And there might be scenario where you need to use this, because if the particular element is not of an integer data type, there are chances that your code might break out. All right. For instance, let's say a is equal to 5, b is equal to, let's put 10, and then when I print a plus b, it would give out the result as 15. You might be wondering, I just printed a plus b. Python is a dynamic language, therefore a is assigned with the value 5 and b is assigned with the value 10, and therefore the result has been given. For instance, comparing the same scenario, let's say I'm just having a is equal to 5 and b is a string, let's put x. Okay, if I try to add a plus b, there are chances that you would error out and your code might break out. So as you see here, because I cannot perform a calculation between a string and an integer type, hence the code has broken up. So now what I want to do is, I want to prevent the error, and I want to make sure that if there are any non-numerical elements, please report that to me. Okay, so how I'm doing it, I'm creating a function here. Do not worry about functions, because those will be covered in our later stages. Now I'm creating a temporary variable, or a variable called total. Total is equal to 0, so I'm initiating the value with 0, because my whole point of this code is to calculate the sum of numbers. And in here, I want to loop through the list, right? So my data list is having all the elements within, so I want to loop through the all the elements within the data list. So for item in data list, I'm checking if it is instance. Okay, if is instance, I'm passing my temporary name, the item, and then if it is either of a integer or a float type. Okay, so I've used comma. So if we have seen previous code, we just provide our individual name, right? For example, like we would just check, okay, check if it is of a float type. But in here we can give combinations as well, because calculations can be performed between a float and an integer. So I'm checking, as long as the item is of a type integer and float, please add it to the total. So you can see that I have denoted in a different way, like total plus is equal to item. So all it denotes is that total is equal to total plus item. So this is the short way you could write it. Okay, so total, this is our usual way of writing, right? Total is equal to total plus item. So what does it indicate? So total is equal to total plus item. I will, okay, I'll show you a simple demo. So for instance, let's say your total is 0, and now you're getting an item value is 5. So if you perform total plus item, then you would get 0 plus, which is, so total has become 5 now. Let's say now I've got the next element, so item is equal to 10, and now when I perform the same total function, so what is my existing total? It is 10. So 10 plus item, what is my item? 10. In that case, my total becomes 20. So whenever you want to perform the total, all we are saying is that, okay, whatever the existing value is, add to your new list value as well. So both your list, I mean, both, I want you to add both the item value and your total value as well. So whatever the total gets added, add it to your item value as well. And now when I print it, I can see that, okay, this is my function. So you might be wondering, I ran the code, why I didn't get the result? Because this is a function and I haven't called out the function. And now in here, I'm creating a list called numbers list, which has 10, 20, 30, 40, and 50.5. In here, as you can see, I've got an else statement which says that if there is a non-numeric item found, print that item to me and skip it as well. So only as long as our elements are of integer and float type, it gets calculated. If it is of any other type, it gets. So in here, I'm creating a new variable called result, and then I've got my function called calculate sum of numbers. So within that function, I am passing my iterable or my list name called numbers. So you might be wondering why I've got data listed. So that is a temporary parameter value that we have provided. So whenever you pass a particular value to an function, this gets replaced with data list. Okay, because that's where you get in to loop for. So that's where your iterations comes from. So whatever the naming convention here it could be, it just gets converted by default to whatever the parameter name that you have set within a. So when I call this, you can see that 40 is a, so that value has been missed out, but the remaining all your numeric elements have been calculated. So this is how you use type checking to perform a calculation. And when you especially design a robust code, this plays a crucial part. Okay, so I hope this session was very helpful to you. So what did we learn today? So we learned about type checking, where you verify the type of a particular iterable. So either it could be a tuple, list, or something else, or you can check the elements within a iterable as well. So that is how you perform the type checking. And then you have, then we looked upon your membership testing. So membership, oh sorry, we learned about length function. So with the length operation, you get to check what is the length, or what is the quantity of elements within a list. And then we learned about the membership testing using in and not in operator. So the in operator looks if the particular element is present, and the not an operator looks for if the element is not present. So in either case, if it is present, it becomes true in an operator, and if it is absent in uh, not an operator, it becomes a true statement. And then we started with the list comprehension, and list comprehension is a way how you write an efficient, performant, and a concise code. So I hope this session was very helpful to you, and we have covered a lot of subject today. I'm glad we are ending up with list, and then in future I'm planning to go with dictionaries. So stay tuned. If you haven't liked the video, please like the video. Feel free to share it with your fellow aspiring Python engineers, Python developers, or any stream that has Python as a part of it. So feel free to share it with your friends who are trying to learn for the interviews. Click the bell icon so that you don't miss on any regular updates from our Data Valley. And also check out our website datavalley.ai, where you can see that what kind of subjects we teach to our students. So domains including like data engineering, data analytics, data science, ethical hacking, Python, Java, C++. We teach multiple domains. So feel free to check out our website at datavalley.ai. If you're comfortable with any regional languages, I have an happy news for you. We do have our channel for Data Valley Tamil and Data Valley Telugu as well. So if you are comfortable with your own mother tongue, feel free to check out those, because we want to bring the knowledge to our regional language as well. So all your learning has been made easier from our effort from Data Valley. So this is an initiative we are doing from our company. So check it out, and I hope all this was helpful to you. So once you end the video, feel free to check out again if you're missing out on any information. And soon I'll be uploading all this information as a notes to my GitHub as well, so you can download it. And maybe sooner I will update when the link has been added, so you can check it out at ease. Thank you so much. We're Data Valley, the fastest growing edtech company of 2025, and we have our headquarters in US, UK, and Dubai as well. And then we have 4 centers of excellence in Hyderabad, and we are soon planning to open multiple centers in Chennai, Coimbatore, in Karnataka as well. So feel free to check our website. We are growing faster, so who knows, we might be next to you, Zuna. Until then, this is Franklin. I'll meet you in the next video. Thank you so much. Hope you all have a nice day. Thank you.